Hello. Hi friends. Welcome to yet another episode of Cloud Native Ninja. This is the continuation of the series that I started building some time ago. We have built Docker images for different components of our application, and today we are going to start with Kubernetes. Let's get started. So far in this series, we have seen how to build a TechTalks application, which consists of a basic front end using React as an application programming language or framework. And then we have built two backend components, one which is the TechTalks producer and TechTalks consumer. We are also using polyglot programming model, and we demonstrate using a distributed application runtime called dapr how to integrate dapr with different programming languages like .NET, Java, Go, Rust. And we are also using message broker, which is RabbitMQ, to decouple our producer and consumer. So far in this series, we have created various different videos, or I've created various different videos demonstrating each of these capabilities: how to containerize a .NET application, how to containerize a Java application, how to containerize Go application, how to containerize React application. So if you have not seen those videos, please visit them, and you can know how to containerize these as Docker container images or Open Container Initiative OCI compliant images. In this video, we are going to focus on Kubernetes, which is one of the most popular open source project. And we can look at the Cloud Native Landscape, or CNCF landscape, which is the Cloud Native Computing Foundation's project, which shows what are the different projects which are supported by CNCF. And if we look at the platform section itself, we can see that there are various certified Kubernetes distributions. These are by AWS, Canonical, there is Rancher, there is Red Hat OpenShift. Then there are also certified Kubernetes hosted distributions, which is the public cloud, or like the one hosted by the cloud provider. Like Azure has Azure Kubernetes Service, AKS, AWS has its version EKS, Google has its Google Kubernetes engine, and various other cloud providers. They also have their own flavor of Kubernetes. Then we also have certified Kubernetes installers. Now, if we look at this diagram itself, and if I switch back to the browser, we can see that there are various different projects which are part of the cloud native landscape, and these are divided. You would have seen me looking at or showing this particular diagram in different videos. So these are divided into database, streaming, messaging, applications, continuous integration, and delivery. And then when we look at the platform side of things, that is where Kubernetes comes into the picture. And this is the small screenshot that I put in my slides to show that the number of projects which are related or built on top of Kubernetes is huge, and the whole ecosystem around Kubernetes is growing at a very fast, rapid pace. So let's try to look at why Kubernetes is so popular and what is Kubernetes in itself. Kubernetes, or also as it is known as K8s, it's an open source project for automating deployment, scaling, and managing of containerized applications. So anything that can run as a container can be managed by Kubernetes. This particular definition comes from Kubernetes website, or kubernetes.io, and it also states that it groups the containers into logical units, or an application into logical units, and makes it easy for management and discovery. It was built by Google initially as a project called Borg, and then it was open source and given to the Cloud Native Computing Foundation. It is one of the most popular project along with Docker. These two are the most voted projects or most popular projects under CNCF. So what makes Kubernetes so popular? The way it is designed or architected is, again, I'm taking reference from multiple sources here to show how people look at it, or how we as consumers of Kubernetes or users of Kubernetes can look at it. At a very basic, it consists of a series of machines which are combined together to form a cluster. And in a very basic scenario, it consists of a master node, and it consists of the API server, which has various controllers and schedulers. Kubernetes makes it very easy for developers to describe what they want their application to be, what we call as a descriptive language or in a descriptive language. Instead of specifying in a very low level language or low level constructs, Kubernetes allows us to define or describe things the way we want it to be, and then it converts these into the inherent Kubernetes objects. When it works with these, it works with the worker nodes, and on the worker node side we have a very important component called as Kubelet, which is responsible for managing the life cycle of our container. It also has a container runtime. This diagram is slightly old, that is why it is showing Docker as a container runtime. But nowadays we also have other container runtimes like the container D, which is used as a better version of container runtime as compared to the legacy Docker container runtime. And then a particular instance of a container in Kubernetes terms, it's called as a pod. Pod is the smallest unit of execution when it comes to Kubernetes. It also has various add-ons like the UI, the DNS, and on the API side or on the master node side, if we look at the details of the components, it also has things like the scheduler, controller, manager. It has a key value store which is called as etcd, or it is based on etcd, and all these worker nodes, these communicate with the master. So when we describe an application, it goes via a API request to the API server, and then all these different components, they work hand in hand to create the complete application. So here on the right hand side, we can see a slightly different version of this representation, which shows worker node 1 and worker node 2. It has a container runtime, Docker, there is a kubelet and kube-proxy. These are the components which run on the worker node. And then it also schedules the actual workload, which is the containers or the pods to run on these worker nodes. So in a very simple term, this is what is the diagram or the architecture coming from the Kubernetes website itself. We have the API, we have cloud control provider or cloud control manager. This comes handy when we deploy Kubernetes in the managed environment or when it is deployed on cloud. When we describe things like we want to create a load balancer, a type of service where we have to expose our service to the outside consumers, where consumers of our service can access it from outside of the Kubernetes cluster. There is a type of object in Kubernetes which is called as service, and this can be exposed in different ways. So if we define it as a load balancer, then that is where a construct like a cloud provider and cloud control manager comes into the picture, where it can automatically decide what cloud resources are required. So let's say you are deploying your application onto Azure. When we use a load balancer service on Azure, it will create a public IP for that. It will provision that in the background. Same way, if it is deployed on AWS or GCP, it will create the equivalent object of that. So that is why it makes it easier for developers to build these applications and provide these high-level constructs to Kubernetes by making these requests to the APIs, and Kubernetes handles it in a consistent manner. If we also go back to the previous slide, we can see that there is a user interface using which we can interact with the Kubernetes API and Kubernetes controllers. There is also the CLI or command line interface, and this is commonly called as Kubectl or kubectl, or some people also like to call it as kube control. This is commonly used to interact with the Kubernetes API or Kubernetes cluster in general. So that's one of the way in which the end user can communicate or interact with Kubernetes, and we will see how to use this shortly. So the common question which comes when we start talking about Kubernetes is, how do I get started? The easiest way for me when I started learning Kubernetes was to try it by hand. I am a person who likes to try out things, and I understand it better when I do it hands-on by myself. And while I was learning, or while I was looking for resources, I came across this very handy resource which I've been referring to other people for quite a long period of time. It is called as 50 Days from Zero to Hero with Kubernetes. It's a bite-sized videos, collection of YouTube videos, links, and e-learning resources created by Microsoft. It's a learning path as part of Microsoft Learn, which is built by one of the co-creators of Kubernetes, Brendan Byrne. And he goes in a very easy manner to explain what are the different components of Kubernetes, what are the different building blocks of Kubernetes, how Kubernetes works, how we should build applications on Kubernetes, how we should deploy them to Kubernetes, and various things around this. And it is structured in a way that you can learn about this from day 1 and it's like day 50. So you would progressively learn different concepts and techniques related to Kubernetes. The other thing that I found useful was the Kubernetes documentation itself. So the first thing I would do to recommend anyone is to install this kubectl command line tool and to have a Kubernetes cluster to play around with. So the first site or the resource that I also recommend is to go over to kubernetes.io and look at the documentation. But sometimes this can be overwhelming because there is a lot of documentation and Kubernetes is quite vast in terms of the different components it has. So my recommendation again is to pick a very simple application and see how we can deploy it to Kubernetes. And that is what we are going to do as part of this series as well. So let's say we got the Kubernetes command line tool or kubectl. I use again Chocolatey, which is my favorite package manager for Windows, and Kubernetes command line tool or kubectl is available as a Chocolatey package, and I install it using that. But you can refer to this particular resource or this particular web page on the Kubernetes documentation to get started with kubectl. Once we have kubectl installed, we also need a cluster somewhere. And there are different ways in which we can create the Kubernetes cluster. If we have access to some cloud provider, we might be able to get the Kubernetes cluster for certain duration of time. But personally, I prefer to install it on my working laptop or my personal laptop. And there are different options available. I started with Minikube, which is one of the single node Kubernetes cluster with Kubernetes features available. There is also Red Hat Code Ready Workspaces or CRC as it is called. There is also Micro K8s, which is a very minimal set of Kubernetes APIs packaged together. These are different options, but I prefer Docker Desktop because Docker Desktop has a single node cluster of Kubernetes as one of the features. Because this is part of Docker, it makes it easier for us to integrate with it and test it easily. So if we go under the settings and look at Kubernetes settings in Docker Desktop, there is this option to enable Kubernetes. And once we enable the Kubernetes, it will start a single node cluster when the Docker Desktop is starting. And we also have the option to show system containers or Kubernetes related containers in the Docker's list of containers. We can also reset the Kubernetes cluster in case we want to delete what is currently running as different objects related to Kubernetes and reset it. But for me, that is the easiest way I've found nowadays to start with Kubernetes. Get Docker Desktop and enable the Kubernetes feature. This is currently running 1.27.2 version of Kubernetes, which is okay for me. But if you need a very specific version, then you might have to look at these other options like Minikube or Code Ready Workspaces or Micro K8s. For my use case, the built-in or embedded version of Docker Desktop Kubernetes works fine. Once we have that, and once we have installed the kubectl command line tool, we can use kubectl to interact with the Kubernetes cluster. And the easiest way to find out is run this kubectl command, which is the top level command. And if you have worked with command line utilities, you know that when we type the top level command, we basically get help if we don't provide any additional inputs. We can see here that there are some basic commands which are also tagged as beginner commands, which are like create, expose, run, set. Then there are intermediate commands like explain, get, edit, delete, and the commands are related to deployments, cluster management, troubleshooting, advanced commands, and the list goes on. It's quite huge. In the interest of time, let me show quickly a command here, which is to know how many nodes are there. So we can use this command called get kubectl get nodes. And since this is a single node cluster, we can see that the node is named as Docker desktop. It's in ready state or status. It plays the role of a control plane, and it was created about 24 hours ago. And it shows that 1.27.2 version, which we also saw in the Docker desktop UI. So with that, that's the easiest way to get started. Now with this, we know that our kubectl, the command line tool, is working. We are able to interact with the Kubernetes cluster as well. Let's look at a very simple command which we can run here. And for this, I again like to refer people to this wonderful documentation of Kubernetes, which is related to the reference commands. This gives us sample or references to all the commands that are supported by Kubernetes. And if you scroll on the left, you can see that the list is quite huge. So we are going to use a very simple command here related to the deployment. Deployment is one of the higher level construct in Kubernetes. Instead of specifying very low level constructs like a pod or a replica, we can use deployment to encapsulate these things together. So I'm going to use one of the command here. Let me copy this and we are going to paste it on the command line. What this command is going to do is it's going to create a deployment named as my-dap, and the image it is going to use is the nginx image. And I want to set this with 3 replicas. Now this is again one of the beauty of Kubernetes, which allows us to create highly resilient applications. And on a single node cluster, we can still have 3 replicas running of our application. So here you can see that quickly it was able to create my deployment. And now if I use the other command to verify that the deployment was created successfully, I can say kubectl get deploy. And we can see here that the name of my deployment is my-dap, which is what I specified while creating the deployment. And we can see that 3 out of 3 replicas are up to date and all 3 are available. This was created about 24 seconds ago. We can also use another command like kubectl get pods, which is to identify the running instances of that application. And here we can see that these are the 3 different replicas of that particular application or nginx pod, all running, all created about less than a minute ago. So we also saw that this is very fast in terms of starting. Imagine deploying an application to a virtual machine and starting it so quickly. This is one of the benefit of using containers, where we can start our applications very, very fast. We can see here that in less than 40 seconds, the application is up and running. In fact, it takes less than 30 seconds to start the nginx pod. So with that, let's move on to the next section. Like what can we do about, what can be done with Kubernetes? When we talk about Kubernetes, I like to use the analogy. Kubernetes can do various things. I like to use the analogy of an airport for managing things. Kubernetes is called the orchestrator for containers. Now, if we look at the airport, the way it functions, there are various things which goes at the airport. Things like it can be running commercial flights, it can be running private planes, it can be running the cargo planes. Somebody has to manage all that. There is also the security aspect to make sure that only the passengers who have the right ticket, they go to the right gate. So there is all this check-in process which is there, the security, scanning, all those things. So if we look at that, all those are divided into separate components in managing the airport. And same way, Kubernetes also makes sure that we have different kinds of controllers to control various things. Again, if we go back to the airport as an analogy, when something goes wrong, let's say the gate which was initially assigned to one particular flight to depart in 2 hours, there is some problem and the gate changes, then we know that the airport authorities, they take right measures to make sure that the passengers, they are redirected to another gate. Same way, when something goes wrong, let's say your baggage was supposed to come on a particular belt, that belt stops functioning, then somebody takes care of making sure that different belt is assigned. So similar kind of things happens with Kubernetes as well. When something goes wrong, Kubernetes is able to provide the capabilities which allows the application to self-heal, which allows the application to auto-correct itself. And that is why I like to use this analogy of an airport to manage the flight operations or different operations related to air travel. And same way, Kubernetes works in similar manner. So that's one analogy which I found very useful while explaining Kubernetes related concepts to new people. So the first thing it does is it orchestrates the container. So we saw here in this example that I used when creating 3 different replicas of my nginx deployment. All I said was take this image, create a deployment with a particular name and create 3 replicas for that. I need not have to worry about where should I schedule it. Kubernetes, the scheduler, it took all that information from me and it managed to deploy 3 instances of my application. So it abstracts the developer from managing those low level things. The next thing it does is it provides a better hardware utilization. If we look at the previous generation or the way we were managing resources, we would always get resources which were like looking at projection for 2 years, 3 years down the line, and these would be over provisioned in terms of hardware resources. What Kubernetes tries to do is it tries to bin pack the resources, which allows us to use maximum resources available at our disposal, and only when we need additional resources it can scale it, or we might go and add more resources. To show one example of this, I'm going to switch to Visual Studio Code where we can define resources. Now what I'm showing here is called as the manifest file. So I'm creating a deployment for one of my application, the TechTalks producer, which I created earlier in the previous videos. And we are defining a YAML based file in a descriptive manner. This approach is called declarative manner, and the one we used earlier using the command line is the imperative way of creating objects in Kubernetes. So we are going to have a quick look at how to create objects using the declarative approach. Here we define a YAML file. We define what API has to be used or what version of the API needs to be used here. The kind of object we want to create is deployment. And then we define some metadata. Instead of going into each and every line of this, I will skip this because we will cover it in later parts of the series. I want to jump straight away to the resource part. We can define resources to say, I want 1% of the CPU core to be allocated to this particular deployment or to this particular instance of my application. And I also want to limit the memory to 200 megabytes, which means that if my application takes more than 200 MB, I'm starting with a request here, in fact, which means that it needs to have minimum 200 MB available on that particular node to schedule. If the particular node does not have 200 MB available as the memory, this particular instance or this particular pod will not be scheduled on that worker node. Same way, I can set a limit saying when the resource usage increases, if it goes beyond 500 MB, there is something wrong with the application. The maximum resource that my application can consume is 500 MB. And in such case, Kubernetes will make sure, the controller of the Kubernetes which manages the deployment will make sure that it kills that particular pod and it restarts it based on the policy. Here we have set the policy for restart as always. So if something goes wrong with this pod, Kubernetes will know that the pod is not functioning correctly and it will restart the pod. So that was about maximizing the resources, and we also talked a bit about self-healing and auto replacement. Application deployment, controlling and automating the application deployment. Again, if we look at the declarative manner of deployments, nowhere we talk about what is the server name or what is the node where we are deploying. We just say declaratively, take this as a declaration or take this as a metadata for my application and deploy. Kubernetes decides where it needs to deploy, taking into account various constraints and various metadata of the application as well as metadata of the worker node into account. It can also be used to run stateful applications. Most of the web applications, if we look at best practices, it is recommended to be stateless in nature. which allows us to scale the application easily. But there are applications which require state, and in such cases we can use stateful applications, and those can also be run on Kubernetes. We can scale the application dynamically. There are features or there are constructs in Kubernetes, something like a horizontal pod autoscaler or HPA, which we can define, saying what are the limits, the resources that our application can work with. And once those limits are hit, do we want dynamically to scale the number of replicas? It can be scaled up or it can be scaled down based on things like the CPU usage or RAM usage. So we can use these kind of constructs which come out of the box with Kubernetes to dynamically scale the application, and the declarative way of managing the services. So this was the example I was showing, where we can declaratively define how the application has to be deployed or how it has to be managed by Kubernetes objects. Resiliency is again built into the platform. We have things like health checks, which allow us to probe for the application to make sure that it is running as expected and take corrective actions. Now, in summary, what we looked at is Kubernetes is a huge orchestration platform. It orchestrates or it manages how the applications are deployed, how the applications are run on a set of nodes which form the part of the cluster. If we want to get started, we can use Docker Desktop, which is my preferred choice at this point in time to start a single node Kubernetes cluster because of the ease with which it can be started. Kubectl is a command line tool which allows us to interact with the Kubernetes cluster. And the thing which I also wanted to cover as part of this is the user interface or the UIs which can be used to interact with Kubernetes. Now, not everyone is so much tech savvy and not everyone is terminal friendly. Like not everyone likes to run commands on the terminal. If you are one of those guys who likes to interact using the visual things or graphical user interface, you can use different tools to interact with Kubernetes. One of them is an open source IDE or visualizer, which is called as Lens. Now, Lens allows us to connect to a particular Kubernetes cluster and see the state of that cluster. We can see what are the different objects which are running or which are created as part of Kubernetes system, and we can look at things like the state of the cluster. We can look at the different nodes. Now in our case there is only one node, Docker Desktop node, so we can see details like the IP address of that, what is the operating system it's running, what's the kernel version, and so much more information regarding the node. We can also look at the workloads which are running on those nodes, so it gives us the overview. Then we can also drill down into specific type of objects like the pods, deployment, daemon sets, stateful set, replica sets, jobs, cron jobs. So these are the different types of objects which are supported by Kubernetes by default. And we can also create our own custom objects which are called as custom resource definitions or CRDs. It gives us an option to switch between the namespaces. So here in all the namespaces, we can see how many pods are running. Currently we have 9 pods running. There is one deployment, there is one daemon set, and so on and so forth. So we can also filter down based on the specific namespace here. So namespace is again a logical construct in Kubernetes to group things, and in one of the future videos we will cover what is the namespace. Then there are things like the configurations, how to manage things like secrets, configurations, config map, resource quotas, limits. So this is like more of a admin thing, how to administer the Kubernetes cluster. And then we have things related to networking, like the different endpoints, ingress policies, what network policies are supported. So all these things, we can visualize them very easily by using this open source user interface called as the Lens. The other one which I have found very useful is called as the Octant, and Octant comes from VMware or Tanzu. So it can also be installed similar to the kubectl. Once we install Octant, we can run Octant command on our terminal and it opens up a web interface. So we can go into the browser and hit this localhost 7777 port, and we will see a similar output what we saw in Lens in a slightly different representation. So we have the namespace overview, we have the workload, similar way like distribution based on the type of jobs like cron jobs, daemon sets, deployments, jobs, and everything. And it also gives a very visual representation of what's going on. So if you don't like working with terminal, you can use one of these. There are multiple of these. I have personally used these two, and that is why I'm showing this. You might be familiar with other user interfaces as well as some command line utilities which are optimized to work with Kubernetes, like K9s is one of the very popular command line tool, which gives us again added advantage of working with Kubernetes by giving things like autocomplete and auto suggestions and things like that. So those are the different ways in which we can interact with Kubernetes using either the imperative commands, what I showed here, or we can use the declarative commands and we can interact using the terminal, or we can use one of the user interface. So here I have shown two of them, the Octant and Lens. You can use your preferred way of interacting with Kubernetes. So I hope you found this useful in terms of understanding what Kubernetes is, how it helps us as an application developer or someone maintaining and deploying the application. It makes life easier for everyone, right from developer to operator and the people managing the infrastructure as well. We looked at the architecture of Kubernetes. We looked at some of the documentation, what are the ways in which we can get started. And with that, we are in a good position to start deploying our application, which we have been building over the period of last few videos that we did as part of the Cloud Native Ninja series. So going forward, we will be using all these different features of Kubernetes. We will deep dive into that and we will see how to deploy that application, how to make use of Kubernetes objects to make our application cloud native. Thank you for watching this video. I hope you found it useful. In case you found the video useful, please hit the like button, subscribe to my channel and share the word. Thanks once again for watching.